Hello, good evening. Welcome to episode number 3 of the series of making a simple game for the Amiga. Let's make an Amiga game in assembly. As you know, or you might have read or you have heard, I don't know, the extension has been released now. It is version 1, as I said, and you can all get it from the marketplace, from the Visual Code marketplace, and install it. Remember, you need to remove the previous version of the extension. Okay? Make sure you do that, else you might have issues. Also, if you have WinUAE on your computer, make sure it doesn't conflict with the extension, because if you are using certain paths, it might conflict. So for your local WinUAE, use relative paths, not absolute paths. That is, actually, let me bring up mine and I'll show you what I mean. So, if you go, unfortunately I cannot make it bigger. If you go on paths, okay, here, these are my paths. You cannot make it bigger, this thing, unfortunately. But just make sure that here you have an icon called use relative paths, and make sure that is ticked. And then where the ROMs are, make sure you have a relative path to the ROMs, not a full path. I had somebody having issues, and to be fair, it's not the exact way this setup is, from what I understood. But from the many people that are using it, that was only one. So I do not know anyone else that had issues. Last time we did or explained what or how the copper works and we created a simple copper bar. Just so that you understand the two instructions, the move and wait of the copper. To be fair, we will not be using much of that. It's much more, I did it only for the sake of explaining the copper. So this is our copper bar that we created. You can see the code here, all this. I am going to remove this because this has nothing to do with the game. Okay? But that same copper bar, okay, There is in the code that I'm sharing with you, there's a snippets, and I am starting to add routines or things that I think that we need to use from the book, or which I'm going to use from the book, and they can be used like a small library if you want of code, but this is code that we will use, modify, or whatever in from the book. By now, um, as always, what I ask is that you go to our YouTube channel and subscribe to our channel and like our videos. As you can see, the videos are there, the streams are there related to the book and to this stream. Okay? As you can see, episode number 2 has been released yesterday and it is there. I will not continue to be releasing this. I mean, this one will be there, also number 3, but there will be a point when I will stop. Um, the reason being is I want to give something to the Patreons. Please, as I said, like and subscribe. Same thing for our Facebook page, okay? And of course, as I said, on Patreon and on Coffee, there are all the latest uh, additions that we have. I mean, if we are at episode number 42, 42 is, or 41 in this case, is on Coffee, okay, of the book. Please, again, follow us on Twitter, Instagram, and Twitch. Join. I mean, I think this is now people are getting used to this. Please join our our Discord group. I can see that the numbers are growing there. Um, if you want to discuss anything related to Amiga coding or C64 coding, or anything related to Commodore, to be honest. Um, Let me find it. The code for this series, can I make this big? I think I can, yeah. You can find it in the link in the video. In the videos, there's a link, and you can download the code related to that episode. So if you are watching episode number 2, then you can download this string, the code that we used for episode number 2, and same thing for episode number 1. The same thing that will be the one of today. So number 3. If I go on the video, I'm pretty sure there's the link, but just in case, I do not want to. Yeah, they are down here. You can see it's here. This is the playlist for all the videos, and the links page, which I will say, and which I will show, and this is where you find the sources. The links page, you know this already, is where I have links related to 68,000 programming. Okay, and I have updated the maps. Okay, and one of the maps that I updated is this one. Unfortunately, the really good one that there was is not anymore available on the net. It was taken off. The website has gone. This is the second best that I found. It is very good. It doesn't have the map for each machine, but you can do without it. But it's quite good. This memory map for the Amiga. The other one that I was talking, it would show the memory map and then the memory map per machine, because there are some variations between one and the other, but very little. And the good thing is also it has the custom chip registers, so um, that's quite handy to have it on the same page. As you know, we are doing this simple game, okay, where we have this guy. It can move left, right, and in the middle. That's the only three positions that it has, and it avoids things while it's falling. Um, I have a crude image, and everything is crude, but things will. I hope that they will. I have somebody that is doing the intro screen image, and this is part of it. This is the crude image that I have, but it's good example to show things, so it's okay. Also, thanks to Hound Dog because he didn't have the patience of doing this, at least for me. But yeah, it's eventually. I hope it will look completely different than what you are seeing here. So, having said all that, I think we should start. Today, we will actually, the first two episodes were more overview and some things. Today, we will actually start the actual game. And I always, when I started the first episode, I wanted to have a screen so that I will be able to show you things. And now that we have it, and I also, you know how the copper works in a way, you should be able to follow much more easier. So, with that said, we need, so we have a routine, we have coded something that will display an image, which are these two routines. Okay, one is the init bitplanes, which I also included them as snippets because they are quite, I mean, they are used quite often. They are common routines, and the other one is init colors. Um, I have added inserted comments to them, and you also find them in the snippets. I mean, I will go through that, but before we do that, actually, I forgot to say something in the um, which is where it is here. Okay, so last time I shared the digital project, but I realized that we do not need it. Okay, I realized that we do not need what we are going to do on the stream. We need what we are going to do for the game. I'm not sharing this. I mean, it's I don't think it's useful to. It's only useful during the stream. Um, but today I will explain the bit planes and colors again, just to refresh. It will be a very quick one. Then um, I will create things related to constants, which I will explain. Then a print routine, which we will discuss from the book. Then a joystick routine, which we will discuss from the book. And then hopefully we'll be able to show the player. I'm not saying we'll manage to do it all, but there's quite a big chunk to cover just by all this. So the first one is explain the init bit planes and explain the init colors. So for that, I am going to show you this diagram. Okay, this is in a way what I explained months ago from on the book from the book. So the Amiga screen is made up of bit planes. Okay, each one of these is a bit plane that can have only bits on and off. So it's only two colors. Each one of them can only hold two colors. But the Amiga, to display more colors, puts them one on top of the other. So here we have one bit, one bit, one bit. So this is Bitplane 1. The red is Bitplane 2. And uh, the black is Bitplane 3. So with one, we can only have two colors. With two bitplanes, we can have four colors. With three bitplanes, we can have 8 colors. If I take the bits that fall on top of each other for each bitplane, that is 7. Okay? And like that, we go and check what value color index number 7 has. I do not have till number 7, I only have till number 4. So let's find one that is 4. So 4 is, so this one, the second one is 001. So 001 is color 1. Okay? So color 1 is, in this case, FFF, red, green, blue. So that means it is a white. The third one is 0, 1, 0. So that is color number 2. Okay, and in this case, color number 2 is F00, which is red, green, blue. So F is red, so it's a red color. And that's how colors and bitplanes are combined together. When we store a bitplane, okay, remember it's raw. It is like taking each bitplane, each one of these, okay, and put them one next to each other. So first we do the blue bitplane, then we store the red. Okay, so down here under it in the file, there will be the red bitplane, and then further down there will be the black bitplane. Okay, and like that, that's how they are stored. So to read them, we read the first bitplane, then the second, then the third. Okay, it's logical. So this routine, what it does is it loads the file, it loads the image, and at the end it has the colors. Okay. So what we do, it's a 4-bit plane. Okay. So we set up the source where our image is. We set up the bitplane pointers where they are in the copper. So if I go to the copper list, here, okay, these are the bitplanes. Okay, remember this is a move, this is the register, and this is the value that goes into that register. We are going to populate that by moving a value here, and then a value here, and then a value here, and then a value here, everywhere where there is a 0. Okay, so that's why the label is here and not up here. Okay, because I'm going to start populating from here. So we got the destination. We got the destination, which is where the bitplane pointers are. And then we have the number of bitplanes, which is 4. I mean, it's 4 minus 1, which is 3, but we start from 0, so it's 4 combinations anyway. Then we take what we have in the 0, which is the address where our image is, and we move word. Okay, so we are moving the low word into 4, A1. So A1 points to this address here. Okay, so where the dollar stands, let's say that. Okay, and we are telling it 4 from here, put this value. So 4 from here, so 4 bytes. So 1, 2, 3, 4. So here we're going to write the low word of the value in the 0. Then we swap. So what was the low word becomes the high word. What was the high word becomes the low word. And we do the same. And notice it is at 0 here. So we are going to write here. Then we swap it back to get the number as it was. Then that was our first bitplane. Then we need to add the bitplane size. So the bitplane is 320 by 256, but 320 is pixels. If you divide it by 8, is 40 bytes. So 40 times 256, comma the 0. So we move the size, we add the size of the bitplane to the value of the 0. So basically, if that was the red one, we go to the black one. Okay. In the previous example that I was showing you on the screen on my whiteboard. And then we add 8. So from this position to this position, there are 8 bytes. Okay, so that's why we add 8 to A1. And we loop that. And we continue populating these registers in the copper. Okay, till we have our bitplane pointer set up. It's all explained here, but I hope that makes it clearer. This one is colors to set up the colors. So the colors are stored in word format after the bitplane. So we have one bitplane, we know it's 40 times 256. So if we have 4 times 4, and we do that in the 0. So we add from where we start the size of all bitplanes. That means we now have the address of where our colors, the colors start. Now A1 points to the colors, which is here, and it's the same thing. Notice here we have it 0, 0, and we're going to populate to change the colors that we have here, okay, because these were testing colors, okay. We're going to have a loop that populates these colors, overrides these colors, okay. Remember, these are the registers. So all we do is move the word that we have in where the image is, okay, so for the color, and we populate it into this value here. Then this one auto increments because it's a word, it will increment to the next one, to the next color. But this one we need to skip, no, because there is the register. So we need to add 4 from this position, okay, where the dollar is, to this dollar, okay, there are 4 bytes, okay. So we add 4, and we continue doing this. We loop basically, and that is how we set up the bitplanes and the color. I had already covered this in the first episode, but I thought I should cover it just in case it is, as a fresher and quickly also. So having said that, okay, now we need to do the next one, which was, if I remember correctly, let me pick it up. I think it was the constants. Yeah. So we need to define bitplane size, number of bitplane, screen size, and number of colors. Okay, so we just go up here, okay? So I'm just going to create Remember, this is a simple game to show you that with what we have covered in chapter 7, you're able to create the game. So let's call this game constant. And we need, so the screen width. So basically, I'm going to replace those values in the end. Okay. So we know it is just 20 pixels. Okay. Do it. The height. We know it is 256. Okay. We know that Bitplane size, okay, is 320 over 8 to get it in bytes times 256. Okay, and number of bit planes. I think it's going to be for my page. So number of bit planes. Okay. So now we can go and change those values that we had with these values. Okay. Actually, no, we can leave it like that for now. So let's do what. Just going to bring them up so that I remember the names. Okay. So let's change this. So number of bit planes instead of that 4. Okay. So that will be number of. Okay. Here, bit plane size. Okay. And here we have bit plane size times number of bit planes. Now, one thing that I didn't define, but I'm going to do it, is number of colors. Which is 16 in this case. So here, this one, E2, number of colors. So now, if we run it, we should still see the same thing, but we are using constants instead of. So if we need to change something, it will be easy to change it here. Then let's say we decide to use 3 bit planes instead of 4. We just need to change that and change the number of colors, because then it is 8, and that is it, and everything remains the same. So now if we run it, it should still run as it should. Control again. Let's see. Hold on. Okay, so last time we did the copy, no? So we eliminated the image. So this is what happened. So yeah, we need to. Sometimes I will leave these because we might need them for debugging purposes. But this is our image to display. So we need to run that one. There you go. So it still worked, but this time we are using constants. And I will be applying this principle of using constants instead of numbers through the whole process of the game. Okay, so I will have a section where I will define constants and where I will be adding these to they will be growing, but um, the more we um, develop the game, the more we will have more and more of these. Okay. Anyway, so we have done another one. So the first three I know that they will be quick. Let's see what's next. Next one is different routine. Okay, so this. So I have already prepared the snippet for it. Okay, so I'm just going to grab that. Okay, and copy it to our code. Now this is from the book. Okay, it's a literally a copy and paste from the book. So I'm going to add it. um, I'm going to add this down here under init colors. Okay. Now this routine is far from perfect. There are things that I know already I'm going to modify. For example, one of the issues that it has, it's not able to print at an X and a Y. Okay, so you cannot specify an X and Y location. It just prints a bunch of text and that's it, as it is. But I want to modify this to be able to print at certain locations. So, first of all, let's test that what we have included is there. The font I should be already, because this I did it in episode 1, it should be already there. You can see that the um, font is there. And we have the magical words Phaze101 rules. The rules is spelled wrongly, it should be with Z. That's the right way of writing it. Um, so, this routine, as it is, okay, I will explain it later, but right now just know what it does. This routine reads this text, okay. It prints one character at a time, this text, and once it finishes by, it knows that it finishes by detecting FF. As I said, it needs to be improved, so we are far from ready to have it as it should be. But we need to be able to write to the screen right now. And I'll explain why in a minute. I also use this type of routine as a way of debugging stuff sometimes. So So um, we also need another routine, okay? And the routine that we actually right now leave it, because I was going to pass to the vertical blank, but we don't need it right now. We can run it as it is using this. Of course, I need to modify certain things from it, but not today. Today we just get it running and I explain it, because even to understand it, you need to be in somewhere. So this is called printing for now. So before the loop, we call uh, this for now it can be .s, but then probably the assembler will adjust it to .word. So print, what we called it, I already forgot. Print. Okay, so I like this for the routine, what the extension does. You know, it's giving us a layout of our code with our, as you can see here, we have our constants, we have our main loop, and then our, let's say, other things that we included into the code. In this case, I have in the copy list, I have already the Sprite data, but or Sprite structures, call them, you know, call them as you like. Um, as you can see, we have our print routine, the init colors, and bitplanes. These are the ones in your orange are our routines, okay, which we are using with a branch to subroutine, which we are calling with a branch to subroutine. So let's see if this will work. Now, text pointer is pointing to here, okay, but that is pointing to our text message, okay. So basically the text message can be anywhere. That's why it's done like that. Let's see if this is going to work. Should, but because we are just going to print to a bitplane. We will might have problems with the colors, okay? I will explain why in a minute, but it should print. Let's run it. Yeah. Oops. So the first one is reference to font. Undefined symbol font. Okay, so where is font? Font should be down here. So it's a link there, funny enough. So where are we using font? Here. And we are getting the address of it. Hold on. Do I have font defined twice? reference to an, oh, because I'm using okay, I think, of course, because I'm using Vasim, not, yeah, it's case sensitive. Yeah, that's why. So now it should be fine. There you go. I still haven't get used to Vasim. It's I'm used to um, Vasim 1, and Vasim is okay. So we have the letter P in the um, upper right hand corner, but for some reason not the rest. So definitely there's something wrong there. Of course, the colors, as I said, will not be right because we are writing to the first bit plane, and it depends what's under it, and then it takes the colors depending on that. No, so why? So we read the character. Okay, so let's go through it now. First of all, we get the address. The address that is a text pointer into 80. Okay, we cleared the two. We move what's in 80. We move byte, so we get the first letter P. Okay, into the two. We compare if it is FF, so if it's end of text. It's not. So then we test if it's end of line, so we can have also 0, 0, okay, which we don't have neither. And then we add yeah, 42-bit plane pointer. 40 times 7 to the bit plane pointer. That is because of the width and height. It is simple jumping to the next line. So if it is not, then branch or not equal to not end of line. So here, okay. So we get the character, we subtract 32 from it, okay, because it's an ASCII, and we subtract 32. I will explain that in a minute. Then we multiply the same number by 8, okay, to get, let's say we had the letter A, to get where it starts in the font. Then we move that value to A2, and then we add the font base to A2, and then we copy it to the screen. So that part is correct. Now here we say add 1 to the bit plane pointer, so we need to move 1 byte to the current bit plane pointer, and we need to move add 1 to the current text pointer. So this moves 1, so we are in the letter H. Of course, we just read one character there, and that's it. Because then it exits, actually, we do not have a loop. Good one. That's why we only printed that. So if we change the first letter, let's say put it to prove our theorem, let's put A. Okay, and we run it, we should see the letter A in the first part of the screen. Okay, I took the snippet, but of course I didn't do a loop. There you go, we have the letter A. Okay, so we already know that we need to improve a little bit the routine, the print routine. Okay, so let's leave it like that. Then we need to branch. Yeah, we need to branch to this, and let's see where we need to go. We need to be somewhere up here. Yeah, we need to be somewhere up here. Actually, no, we need to be up here, so we need to be on top. Okay, so let's test it out with print info, but I will change it a bit because I'm not liking it. As I said, this was copied from the book. I'm already realizing that this is not what we need. I mean, it is what we need, but we need to enhance it. So let's run it. I'm not saving because each time the extension saves, okay? There you go. Phaze101 rules is there. Of course, as I said, the colors are not okay, but it is there. And it exits by finding this FF. So when it reaches this part, it knows it needs to exit. Okay, so let's print just Phaze101, and let's print it on the part where it is red. Okay, so that is, we need to add to the Bitplane pointer a value. So the Bitplane pointer needs to be we need to be hold on. We are starting from the beginning. This one we need here. We need to move it plus, and that would be, let's say there are 30 characters, so 30 times plus 30 because it's in bytes. So now we should see Phaze101 printed towards the right of the screen. There you go. We need to move it one more character to see it properly. So that would be 31. There's a reason why I need the print routine. Um, we will need to write text to the screen now, so a print routine is needed. Right now it's very crude. We just have a text and then you print it to the screen. And there you go, it's in green. Now that green, okay, somewhere we have green defined in the copy list, and we can actually change that color to whatever suits us. We are writing in Bitplane 1, so let's say we wanted to write in Bitplane 2, okay? So what we do, so that is screen Bitplanes. Let's find screen Bitplanes. I think it's at the bottom. Screen Bit, yeah. So if we need, let's say, right, instead of Bitplane 1, we write to Bitplane 2. So we need to do what we define those constants that we used. So Bitplane size. We need to add a 1 Bitplane size now. So now if we run it, we should see it, and it's in a different color. I'm going to leave it like that. It's okay. The colors are, I'm going to explain why the colors are like this, but it makes sense. We can see whatever we type, what we have on the screen. Let's say we want to pass something there, we can see it. Okay, so I'm going to use the HUD, let's put it this way, as an area where I can print things if needs to, when I am debugging. Okay, so I'm going to use the print routine to write text to the screen, but also I'm going to use it to write, show me things to the screen if I need to debug stuff. And for now, the colors, it's not an issue. They do not affect us, no. Okay, so the print routine is working, and I'm going to show you something related to the print routine. So I believe I have a note in the I need to bring this up, and page 67. So let me find the page first. So so there we go. So I'm just going to bring the book a little bit, okay, just to show you something. Okay, so our font, okay, is stored. I mean, our font that you see on the screen is stored, of course, in a byte, but is composed of 8 bytes. It's the height of it is 8 lines, okay? So it's 8 pixels high, and the width of it is 8 pixels also. So each 8 pixels makes 1 byte, so we have 8 bytes for the font, okay? So when we want to print, okay, in the code we have this part, okay? We have move whatever we have in A2 to A3, etc. Basically, we are taking each line of these and we are moving it to the screen, okay? And every time we do that, okay, we are multiplying. You see the values here, 40 times 0 is 0, 40 times 1 is 40, 40 times 2, 40 times 3, 40 times 4. That is, when we take the first one, okay, it's 40 times 0, so we just print it as it is. But the next one needs to be in the raster line, one line under, no? So that is, we know that the width of the screen is 40 bytes. So we need to add 40 to print the second line. Then we need to add another 40 to print the third line. And we continue like this. And this is how it is being, why we have this 40 times the number, so that we can print the whole number. Now, notice also that last one, okay, is a blank line. So in a way, okay, we can, if we start from 0, so 0, 1, 2, 3, 4, 5, 6. The last one, we can also skip it if we want to, because it's not, there's nothing in it, okay, in this case. But in theory, we print it, okay? We just print the value that there is in relation to it. But if we wanted to save, we could not print the last one, okay? We print from 0 to 6, okay? So that means from 1 to 7, and we skip the number 8. Now, the font is stored, I think the book shows it earlier. Yeah. That is our font. It's stored vertically. If you want to imagine it, it's stored, each character is stored one above the other, so, or under the other, okay? If we look at an ASCII chart, let's find the ASCII chart. It should have one. No, I don't. Okay, let's find one. ASCII. Okay, so we know, let's say the letter A, okay? The letter A is, where is it? Starts at 65, okay? 41 hex. Our font starts from number 32, starts from here with a space, okay? So we deduct the 32 because we do not need to, we need to ignore this. So whatever value we get, okay, for this, we always deduct 32 or 20 hex because this is where we start, okay? So in the code, you're going to see these two things. One is what I told you, and I made it more clear by multiplying by 0 and by 1, which is the same as like 40 and 0 basically. So that is for printing the character. Okay, and here somewhere we are subtracting, there you go, the 20, which is 32. So that because we start from the space, so our first character is a space, okay, in the sheet, in our font sheet, okay, in our what we call it, nice font, okay. The way it is stored, the first character that there is a space, okay. So because we have that, we do minus 32 because that is our start, and then we, whatever the answer, if it was A, okay, it was the letter A. So then we know that the letter A is 41. 41 minus 20 hex. 41 is hex, and it's 21. So we multiply 21 times 8, because this is a multiplication by 8. Okay, logical shift left. We are multiplying by 8, and um, we get the start address of where our letter is. So the pattern for our letter where it is. Now, last time I get it back. Last time I'm going to keep this because we will need it. Last time I showed a website. I think it's this one. Yeah. Last time I showed this website. Okay. There is a link to it in the links. Okay, in the links page. Okay. And when you want to learn 68,000 code, I mean, you do not need the detail of huge books. Okay, I have this one, and I have other books, but you do not need, in the beginning. You do not need a lot of detail. Okay, so by looking at this, where did I put it now? Yeah. Okay, and let's say we want LSL. Okay, so let's find LSL. It's here. Okay, part 6. We just click there, and he explains LSL quite easily. Okay, you do not need, all you need is this. Okay, to read this for LSL and nothing else. So it's quite handy, this website, to learn quickly, or to learn, understand 68,000 quickly. I'm not going to go into the instructions of the 68,000. We have already covered them in the book, and I am assuming if you want to write again, and you start writing again, you have to know some 68,000 code. I mean, else how can you do anything, you know? So this is quite an important part, that you need to know, quite an important thing. Anyway, now so we have our print routine, and it is ready there, uh, displaying text on the screen. Now, why I wanted the print routine? If I want to test something and want to write a value, what I need to do is write to text message. The value will be here, and what value I store here, it will be displayed to the screen. Now, the value will not be a number, okay, it will be ASCII, but I can decode it, and I can find out what it is if it needs be. Okay, so this is, maybe it sounds a bit advanced, but sometimes you need to find what you are passing, what's happening, and you just copy here in this part of memory. I can pass a long word because 4 bytes are a long word. Sure, I can pass 2 long words in Phaze101, so it's more than enough for what I need, at least for now. So I will use this text message to even write to it if needs be when I'm testing stuff. Now, notice our loop. I am not quite happy with this, with the way we wrote our loop. Okay, this is correct. We initialize, okay, our bitplane and colors before we set up the copper, okay, because here we're telling the copper to start, so I prefer to have those before, okay. Then we are printing to the screen, but then we end up in an infinite loop. Therefore, and this I am going to get from one of my codes, I mean this is from the book basically. I am just going to add, it makes more sense right now to have this. Instead of having an infinite loop, I prefer to have the press left mouse button, okay, and we loop. It's good sometimes to exit the OS, and I will show you why later on, but I know I will need to exit to the OS. So now if we run it, okay, I have some, yeah, volume is more. So now we have our image, we print to the screen, and then when I press the left mouse button, I should exit. And it closed the WinUAE, but eventually it will not close the WinUAE. It will exit. We will exit it to the shell. I will tell you later on what we need to do, because I would like to be able to run certain things from the shell to test certain things too. For example, sometimes you need to run monam in the shell, okay, and then run your and then run the code. Or I know some people prefer WinUAE and use the debugger of WinUAE, but visually sometimes monam is quite good to see everything in one picture. Anyway, this is all me doing futuristic thinking. Okay, so now that we are able to display a screen and write text to the screen, and we are able to exit, there are few things that I need to explain. First of all, the extension has got this file, settings.json. Okay, if you click on it, it tells you where it's WinUAE, okay, and it's FSUAE R, okay. So you can go here and modify them, but I do not advise that. What I advise is that you change this path to your path. You copy them to somewhere where you want, and you change them to your liking, and then just point this settings this settings JSON to what you like. I will not be doing this right now, but later on I will be doing it because I want to test with Kickstart 1.3 and Kickstart 3.1. Okay, right now we are running on arrows. It's okay to run on arrows, but we need the Amiga kickstarts in the end to make sure that everything runs on a standard Amiga. Right now we are still far away from that process, okay? But now that you can change, see where the spot is on your machine, copy the directory, okay, modify FSUIE and WinUIE the way you like, and then change this path to your modified version. It's the simplistic way of doing things. There are other ways of doing it, but this is quite handy. And to be honest, I created one which was common. So basically, I'm sharing this. I called it common, so all my stuff will use common, and it will be where all my FSUNE and WinUIE will be. The other thing is this directory UAE, okay, has got a hard drive, okay, and in your hard drive you have a C drive, okay, you have the C directory, not C drive, and you have the S directory. In the C directory, okay, you have UAE quit, and in the S directory you have the startup sequence. This is what calls your program when you run it, okay. I will be adding commands to the C directory later on, okay. So keep this in mind. I will be modifying this just to make it, let's say we want an image to load while it is loading. We can do it here, okay, in the startup sequence. Anyway, these are all things we will do at a later stage, but I am explaining to you things that will come, and maybe for those that already know enough, they can go and start modifying the extension. There is going to be another update to the extension with better, let's say, better ways of emulation. Okay, so what's next? Let's see what I have next in the list. So if we go to our Twitch, sorry, GitHub, not Twitch. Okay, we did the print routine, so I explained these. My God, I forgot to move them. Explain it in colors. Explain the constants. Explain the print routine. Okay, so we're going to do read joystick. Now, this one I also have a snippet to it. And I tried to make it as easy as possible. I'm going to copy it and then I explain. I'm going to copy it under the printed form. Okay, so as I said, this routine reads the joystick port. Now, the Amiga has got two joystick ports, one for the mouse, port 0, and one for the joystick. The registers for them are DFFOA and DFFOC, known as Joy 0 dot and Joy 1 dot. Okay, that's how they are known. Again, this is from the book. So for now, we have used routines from the book. So don't think everything is going to be from the book. This is the initial, let's say, part for our game. Okay, so these are In a way, it's an easy way of me introducing you to the game and you understanding the code. So the joystick routine, okay? If we read bit 1, if bit 1 is set, then we move right. If bit 9 is set, we move left. But for up and down, the Amiga is a bit strange the way you um, you know if the joystick is up or the joystick is down. So you take bit 8, you OR it with bit 9, XOR it, sorry, with bit 9. If the result is 1, then you move up. You take bit 0, XOR it with bit 1. If the result is 1, you move down. And this is what we are doing here. Now, our game is only going to use left and right. Okay? For now, I'm going to leave up and down. But the game only uses up and down. Sorry, left and right. So, notice what it does. Okay? So, as I said, the FFOOC is the joystick port. So, we read the joystick port and we store it into the tree. Okay? Then we test bit 1, okay, of the tree. If it is at 0, then we check for left. We are checking for right. Remember, bit 1 is to move right. If it is to move right, we add 1 to the sprite x. Sprite x is just a value that we have, a memory location that we populate. Okay, so right now we are not yet moving the sprite. Okay, then if we are moving left, we test for bit 9, as I said here. If we are, okay, so if the test is not equal to 0, so we are, okay, so it's a 1, so then we subtract 1 and we move to the left, okay. Here is the y part, okay, whether we move up or down. It looks complex, but it's not, okay. So we take the value d3 and we move it into d2. We move it somewhere else because we're going to work on a temporary value. We shift it to the right by 1. Okay? So we shift d2 to the right by 1. We XOR it with d3. So remember, the value of d3 is in here, but we also copied it in d2. However, d2 is shifted to the right by 1. If the value, okay, of the value of bit 8, okay, is a 1, then we are moving up and we subtract 1 to the y. If we are, if not, we check for the up direction. We test bit 0. We don't need to do this part now because we already done the operation. Okay, so we test d3 for moving to the moving down, because that was the up. If bit 0 is a 1, okay, we XOR them by with 9 and 1, but we test 8 and 0. Okay, if the value is a 1, that means we are moving 1 down. Hence, we add 1 to the y of the sprite coordinate, because these are just coordinates right now. We are not doing anything. Okay. Now, first of all, I need to run what we have. Okay. And make sure that I have the joystick configuration set up correctly. So let's run it. And I want to see when I press F12 what it detects. So I'm sorry you cannot see this, but input, sorry, game ports, and I'm hoping it detected my joystick. It did, which is in game port 2. So no, the only caveat of this, I think it doesn't remember it. So if I go to configuration, tell it to save. I don't think it will remember it, but okay, let's try. Anyway, so we will see when we run it again if it will remember. Okay, so I explained the joystick routine, but we are not calling it and we are not doing anything with it. So to do something to it, we need to have a sprite on the screen. Okay, so now we come to the part where we display a sprite to the screen. So in the beginning, okay, in episode 1, I already set up the couple list with all the sprites, but this is the sprite that we need to work with, the player sprite. All the sprite definitions, okay, for our game are there, but they will change eventually. But for now, it's always going to be for the players, always going to be this one. Hence, we need to initialize it. We need to initialize the sprite pointers to point to SPR0. Okay. Now I'm going to explain it a bit. A sprite is made up of data for the sprite, which is this. Okay. And is made up of 4 bytes before the sprite data and 2 words at the end of the sprite data. The 4 bytes or 2 words, same as at the end, are, okay, one is the V start, where we start vertically. One is the A start, where we start horizontally. Then is the V stop, where we stop. So it starts drawing the sprite, and where it stops drawing the sprite. So in the Y, it's called V stop. And then there is 1 byte which has got special bits in it, which we turn or enable, or we read, or we do what we need depending on the type of sprites and what we are trying to achieve. I will explain later this. For now, what's important is that you know that we have a Y value, we have an X value, and we have a YN, because a sprite has got a certain height. So you have to tell it where it ends. The H value is specified for now, okay, every 2 pixels, not every 1 pixel. Okay, so if we enter the value 10, okay, we are actually in position 20. Okay, it's When I said position 20, maybe it's wrong saying it like that. Um, we only have, actually, this is better way of saying it. We only have even positions. So 0, 2, 4, 6, 8, 10. That's what we actually have. So forget what I said that we have entered 10, it's 20. It's not really right. It is positions in multiples of pair positions. I mean, even positions, okay? That's the what I should have said. Okay, so we have, this is our sprite structure, this is our data, okay? This is the data. Now, a sprite has got like 2-bit planes, if you want to call them like that, to form its data. It is made of 4 colors, but one of them is transparent. So it's like having 2-bit planes, one on top of the other, okay, to define the sprite, okay? A good place to start uh, editing sprites or writing sprites, okay, is to use this tool from Ozzy. I'm not sure if he's still on, but Ozzy has got this tool, okay, where you can design a sprite, okay, just, and then it will show you binary, hex, Amiga colors, and sprite binary code. This is, look, each line, okay, each line is made up of 2 words, okay, the last one, the last, you cannot see it, I guess. Oh, you can. I was saying, if you click on sprite binary, okay, it will convert what you have here into what you see on the screen, and this is what we are using. This is how I got my data. I use this tool to get my sprite data that I'm going to show on the screen. So the last 2 words are means terminate. I mean, this is our sprite has finished. The first 2 are the v start and the h start, and then we have the v stop and the special word. Okay. Colors, this is the colors that we are using, so they are defined here. You can see it in hex, the values that we have there, or you can see it in binary. Normally, to the assembler, you copy this, okay? You just copy and paste this. I just changed a bit the format of it, but it's the same thing. No, Ozzy is not here. So, we have our sprite. We defined our sprite, but we are not seeing now it on the screen. Why is that? It's because the copier has got pointers, has got registers that we need to tell it, hey, this is where our sprite is. Hence, we need to update the sprite pointers with the pointer of this sprite. Apologies, I need to drink something. So, we need to write another routine. And this one is to initialize the sprite. Hence, let's close this. Let's go under the joystick and let's create this. To be honest, should be further up actually because it will be in the initialization process also. So this should be under init colors. Yeah, init colors. So let's write this routine. Hopefully, I make no mistakes because this should be quite straightforward. So init sprite. And we will have sprite and we always yes. Now in the copper we should have our sprite pointers. There they are. Now this is, we are only going to populate sprite 0. Okay, so we need to write a value here. This is the high word and this is the low word because it's an address, it's a long word, but we need to divide it into this. Okay, so we need to get what was the name? Sprite 0, was it sprite 0? It is sprite 0, okay? Where all the data is called sprite data. I mean, these two labels has got the same name, but it's sprite 0, okay? So let's do sprite 0. And let's keep it. What I was showing before. Let's do long. I cannot use LEA because they are crossing sectional, okay? Sprite SPR0. Then we need, that's what I was showing before, where our sprite pointers are. Okay, so then we need sprite pointers. And this is the first one. I could have used N0, N0, not using. So now that's what I typed. Then we move the word, okay? So the address of sprite 0, which is in the 0. So p0, comma 6 bracket. I tell you why 6, and that is a1 because I use a1. So I could have put sprite pointers down here. I didn't do this for sprite 0. So the first one that we need to write, we're going to write the low byte, the low word. So it's this one. From this, let's say $sign, to this $sign, there are 6 bytes. Okay, so this is why the 6 in front of the A1. So the A1 is where this label is, and we're telling it add 6 to it. So then it's like what we did with the bitplanes, swap 0, and then move the word did 0, comma, think you can guess. It is 2 now into A1. So that is our Sprite initialization routine. So we call it like the others, okay? Here, so here we're going to initialize our player and display him on the screen. Okay, so let's see. Now, I haven't explained something, but I'm just going to run it and then I'll come to it. Let's run it. Notice that I'm not using the debug mode every time, only if I need to. I will run the debug mode. Oops. It didn't like what I did. It didn't like the fact that I saved. And I hope I didn't ruin it. Uh, let's run it again. Because it's remembering even the screen size, but I think I override something in the extension now with this. So not happy. So 12. So this I override something. I should have made a copy of it before. Yeah, even remember the joystick. Damn it. So I'm just going to I think the quickest way, because now I do not want to be debugging the extension. Why I did it? I'm just going to uninstall the extension and install it again. Where's the extension? Here it is. Yeah, reload is required. And then we need to install it again. So Amiga install. And we should have our extension. Again, let's hope that this time it runs. Yeah, I should not have done that, because in next release there should be changes to uh, help in this. Okay, so let's run it. I'm convinced that it like it now. So, okay, well, let's not call this routine to make sure it's not the routine. And that's right. Okay, I need to fix it. So, the routine is using, let's uninstall it again. We need to delete the directory basically. We need to go and delete the directory. So uninstall, reload. So it's not there. Now we should, this is where the extension is. I am going to delete it. There shouldn't be here, nothing. Yeah, I think I should be okay if I delete this, and then it should create it. So let's install it again. Install. Yeah, as you can see, it created it again. So now, if I go back to where we were, I should have the default thing as we were. So let's run it. Definitely it's better, because that's how it should look when you run it. Oops. Ah, I clicked the wrong one. Cool. Let's run it again. I pressed the wrong key. There you go. But we don't have our sprite. That is because, if you recall, we didn't call init sprite. So now we're going to call init sprite. There you go. We have our character on the screen. Okay, mission accomplished for now. We have our sprite on the screen. Of course, right now the sprite doesn't move as it is. So we need to move it. I can show you what we need to change to move it. So right now it is in this position. Let's move it. Let's say, let's close this. Let's find the sprite. There you go. And instead of 80, let's do 70. This is the age, okay? So we're going to move it 16 pixels to the left. And let's move it further down. I don't know. Let's move it 8, okay? Further down to the screen. But then if that is A, okay, remember we have to add the height. So this should be B, because it's 16 by 16 our pixel. So we need to tell it that. So now let's run it again, and it should be somewhere just below the middle of the screen, I believe. And more to the middle of the pipe. There you go, much to the left of the pipe, and it is in the middle of the screen, as I said. So what we did, let me see if I'm able to show it. Yeah, you can see 80 is, we specified this corner here because the sprite is in the upper left corner. That's where the coordinates are, the pin is, let's say that for them. So it is here. And then we set the horizontal position is 70, so it is this position, okay? Where you see whatever 70 is in pixels. Then we told it bit 0, it ends at bit 0, okay? This is 16 pixels high, okay? So it ends there. So it starts drawing it and it knows where to end. So that is our sprite on the screen. Let's put it, shall we do 50 and here 60? I think, is that acceptable? It needs to be a bit higher. So let's do 4 and 5. Should be fine now. It needs to be at the top, but not to the most top. You need to see that the sprites, the enemies, go behind it. Yeah. Now the screen, okay, why we specified for 0, okay? Why is that? Well, it's simple. We have a black border here, okay? The screen starts somewhere here. So between where it starts till here, it's 2C. The first value, the first Y, is 2C. That is 2C. I always forget what it is. 2C in hex. I know it in hex, but I don't know it in decimal. So if we write 2C, that is 44. So the first line that we see on the screen, oh, it doesn't grow here, is 44. Okay. Okay. So we didn't. So we have our sprite on the screen, but I'm contemplating if I should make it move or not. I think I'm going to stop here. Yeah, I think I'm going to stop here because then it will require something else, and I don't think it's a good idea. Okay, so next time we'll be moving the sprite on the screen and we will controlling it better. I'm going to this one. I'm going to update our GitHub. So read joystick routine. I'm going to show player. We actually did this. Read joystick routine. I'm going to put it there, and we actually showed it to the screen. So that's there. Read joystick. We will need to return back to it. Okay. So we know next time we will have for sure the joystick. We need to continue to expand. We need to do the weight raster. Probably a random number generator, but I'm not sure. This is a tricky one. Actually, we need to do move the player left and right. But first, we need to do that. Okay. So the code will be available. Okay, as always, I'm going to say all will be available in this episode for sure. Probably also the next one. We will need to get the player at least moving, so that you guys can start following me better. So I hope you have a good weekend, guys. Um, I hope you had a good weekend and see you tomorrow for the book. We continue with the Blitter. Um, Hopefully, we will not finish it tomorrow, but it's an interesting topic tomorrow. It's double buffer, so it's quite an interesting one. Anyway, see you next week. Have a good week. Thank you. Bye bye. Bye bye.